The topic is separation of mixture of amines. When a mixture of primary, secondary and tertiary amines along with quaternary ammonium salt is formed during certain methods like ammonolysis of alkyl halide, it is distilled with potassium hydroxides and mixture of amines, distillate and non-volatile quaternary salt is left behind in the flask, and the mixture of the amines thus obtained is separated by either of the following two methods. The two methods, first is Hofmann's method and second is Hingsberg method. The first method is Hofmann's method. Hofmann's method. In this method, the primary amine, secondary and tertiary amine is treated with diethyl oxalate. The first is the primary amine form dialkyl oxamide, which is a solid. This is the diethyl oxalate COC2H5, COC2H5. This is the diethyl oxalate, that is 1 mole, and react with the 2 mole of primary alcohol. This is primary amines, 2 mole, and release 2 mole of ethyl alcohol and form this oxamide. This is dialkyl oxamide, which is solid, and side product ethyl alcohol. Second is the secondary amines form dialkyl oxamic ester, which is oily liquid. The secondary diethyl oxalate react with 1 mole of secondary amines. This is the secondary amines. This release 1 mole of alcohols and form this dialkyl oxamic ester, and which is oily liquid, and 1 mole of ethyl alcohol. Third is the tertiary amine does not react at all, that is no replaceable hydrogen atom. It is recovery of amines. How the amines are recorded? The mixture containing oxamide, which is solids, dialkyl oxamic ester, which is oily liquid, and tertiary amines is distilled. Tertiary amine being volatile, distiller, and is collected. The residual mixture containing a solid oxamide and dialkyl oxamic ester may be separated by simple filtration. Oxamide this is oxamide. This react with the potassium hydroxide QH to regenerate primary amines, and the potassium oxalate, the primary amine is recorded. Secondly, this oxamic ester, this react with the potassium hydroxide to back regenerate secondary amines, and this potassium oxalate plus ethyl alcohol, and the secondary amine is recorded. Next method is Hingsberg method. In this method, the mixture of primary, secondary and tertiary amine is treated with benzene sulfonyl chloride. This is known as Hingsberg reagent, and then by 5% aqueous potassium hydroxide solution. First, the primary amine react with the benzene sulfonyl chloride, form N-alkyl benzene sulfonamide, which is soluble in aqueous potassium hydroxide solution due to the formation of salt. This is the primary amines react with this benzene sulfonyl chloride, release this HCl minus HCl, and this SO2 NHR, N-alkyl benzene sulfonamide, and which is soluble in potassium hydroxide. This is the base. Abstract the proton here, and the salt is formed. SO2, this N negative, K positive, and R, this is the soluble salt. Second is the secondary amines react with benzene sulfonyl chloride, forms NN dialkyl benzene sulfonamide, which is insoluble in aqueous potassium hydroxide, no replaceable hydrogen atom on nitrogen atom. This is the secondary amines. This is the secondary amines react with this benzene sulfonyl chloride, release this minus HCl, and form this SO2 N R2. This is NN dialkyl benzene sulfonamide, and which is insoluble in QH solution. Third is the tertiary amines does not react at all. No replaceable hydrogen on nitrogen atom. Next is the recovery of amines. Recovery of amines. The alkaline mixture thus obtained is extracted with ether. Tertiary amines and dialkyl benzene sulfonamide being insoluble in water pass over to ethereal layer, while potassium monoalkyl benzene sulfonamide remain in the aqueous layers. The two layers, aqueous layer and ethereal layer are then separated. Next is recovery of amines. Recovery of amines. The potassium monoalkyl benzene sulfonamide C6H5SO2 K positive and R. This hydrolyzed with the HCl to form this C6H5SO2 NHR. This is N-alkyl benzene sulfonamide and this KCl, and this benzene sulfonamide undergo hydrolysis with the concentrated HCl, form this benzene sulfonic acids and primary amine hydrochloride, and this primary amine hydrochloride with the potassium hydroxide undergo distillations, from this primary amine is recovered, and this is potassium chloride and water molecule. Next is recovery of secondary and tertiary amines. The ethereal layer is subjected to fractional distillations when first ether distill and free tertiary amines being volatile pass over, leaving behind this solid dialkyl benzene sulfonamide. This C6 N-dialkyl benzene sulfonamide undergo hydrolysis with the concentrated HCl to form this benzene sulfonic acid and this secondary amine hydrochloride, and this secondary amine hydrochloride react with the potassium, undergo distillations to form this secondary amine is recovered, and the potassium chloride and water. Next is physical properties of amines. First is color and stability. This lower amines are colorless, and amines they are colored, particularly aromatic amines on standing in air they form colored oxidation product. Second is toxicity, particularly aromatic amines are toxic and should be handled with care. Next is boiling point. The amines have higher boiling point boiling point than the other compounds, and they are polar in nature and they form intermolecular hydrogen bonding. This is the primary amines. This is the hydrogen bond. Second is solubility. The lower amines are soluble in water. The amines form hydrogen bond with water. This is the ammonia, and this is the hydrogen bond. This is the hydrogen bond. Aromatic amines are insoluble in water. The hydrocarbon part which causes steric hindrance and resist the formation of hydrogen bond with water. बस